Hello, and thanks for joining us today. Today we're going to be talking about the GSA replacement, which if you're on the call, and I'm sure you're familiar with that. Let's see. So we'll start off with talking a little bit about what the GSA is. Surely everybody knows, but we'll give it a rundown anyway. So it's a rack mount enterprise search appliance. Looks a little bit like a block of Swiss cheese. And the goal of this thing is to provide a single point from which all of the important information across an enterprise can be searched. So it's an enterprise search device. Sometimes you're using this for internal users. Sometimes it's being used to service search for external users. Sometimes it's a little bit of both. I've seen it both ways. This is all accomplished by the GSA indexing different kinds of documents from disparate sources like file systems, databases, internet sites, wikis, SharePoints, applications like ERP systems, content management, CRM, SRM, so on and so forth. And then it provides APIs and a user interface for searching them in a uniform manner. So it could be end users searching it, or you could link applications into this thing and provide search through a non-GSA provided interface. So that's a lot of moving parts, not terribly easy to replace, so it's going to take some thought. There's a lot of solutions out there, so we'll touch on the different types of solutions that have sprung up for replacing the GSA, and how you might roll your own type of solution to fit exactly your needs. So each GSA unit, depending on the model, is capable of indexing either 10 or 30 million documents. Really, for modern search technology, that's not a whole lot. So there's plenty of options out there that can handle that kind of volume, and we'll touch on what some of those things are. And this thing scales up by adding, it scales horizontally by adding additional nodes. You can't mess with the hardware, so horizontally is the only way that you can scale this thing up. Fortunately, the licensing for replacement units for the GSA are a little bit more favorable for the consumer, because you don't have to buy a new box, and it's usually not licensed by the number of documents you're indexing like the GSA is. So that's the basics of the GSA. In 2016, Google sent out a letter to all their customers letting them know that they're no longer going to support it past March 2019. The way the license works, it's not only going to not be supported, but it's going to stop working. So that kind of puts the heat under anybody who's got one of these things to replace it. Google's doing this because they really want to push everybody onto their cloud solutions. That's not really palatable to a lot of enterprise users because they don't want to give up control of their documents. They have policies against moving stuff to the cloud, so on and so forth. Aside from that, if you have a whole lot of documents, it's pretty cumbersome and slow to push all that stuff out of your private network into the cloud. There's all kinds of problems with that where it's not going to work. So we'll come up with some solutions that will. So the first thing that you need to do is decide what your goals are with regards to replacing the GSA. You can either replace the GSA straight away, no new features, don't change anything, as minimal a disruption as possible, just keeps the existing applications running as quickly and as non-invasively as possible. You can try to slim down your search budget, address only the features that you think you're really leveraging off of the GSA. It does try to do quite a lot, so if you're only using a small subset of the functionality of the GSA, it's possible to come up with a simpler solution that costs you less money. And then finally, what most people I think are going to be interested in is the replace and extend type of case where you want to overcome some of the limitations that you had with the GSA leverage some of the new search technology that's out there and improve your capabilities, provide better experience to your end users, and also to, since you're going to have to support this thing no matter what you do, at least to some extent with your own IT, you're going to want to make this thing as supportable as possible. So we have 3 different courses of action for replacing this thing. So the first and cheapest one is going to be to use open source. I know that's not doable for a lot of organizations that have kind of a no open source policy. And it's probably not the best option for most people anyway if you need to scale up to true enterprise scale documents. But there is a solution out there. We'll touch on it. It's kind of a trade-off between effort, flexibility, and capabilities, because there's a decent open source solution out there that touches on all the basics. It doesn't do anything great. Most people don't really need it to do everything great. You can buy commercial support for it. So if you have a pretty small user base that's using your enterprise search and it's not customer facing, then you might look at that as an option. And then what most people are going to be interested in is the finding a packaged commercial solution. You're just looking for another commercial packaged solution, just like the GSA, that replaces everything and hopefully gives you a little bit more functionality. Ideally, that's going to be your least effort involved. You're not going to have too much engineering effort involved. It's probably not going to be the case that they have everything that you want. You're probably going to have to build at least one thing, a connector to a data source, extend the UI, something like that. But it's also the least flexible solution because you kind of get things the way that they prepared them for you, just like you had with the GSA, but it's probably going to be, some things work a little better, some things don't work quite as well as the GSA, but you get whatever it is that you buy. Fortunately, there's a lot of options out there, so you can kind of play with a variety of different options and see which one's going to work out the best for you. And the cost between these products varies from pretty inexpensive to crazy expensive. So lots of things to think about with regards to the packaged commercial solutions. Then there's the good old roll your own solution. That sounds like a terrible deal to most people, but it's really not that bad because there's some pretty good search technology that's out there. Most enterprises have enough engineering staff on hand that's used to building pretty simple UIs. A search UI is not a major deal as far as application development goes. That'll probably be the smallest part of your enterprise search solution. It's not hard to build a decent UI for searching and returning results. It's pretty basic stuff. And there's pretty good search engines out there that you can use as a data store that scale and are very performant, way better than the GSA itself. And if your use case is, pretty narrow, where you're serving a pretty targeted user base and you're not pulling data from too many data sources, this is probably your easiest option, and it's also your most flexible one. You're going to be able to do more things with it for a minimal engineering cost. Probably on par with most packaged commercial solutions. The only time that it's not really going to work out for you is if you have to collect data from a ton of different systems, or you have all kinds of user profiles that you're going to have to support, where some people can see some data, some people can't see it. If it's really complicated, rolling your own might be prohibitive. All right, so your open source option, and this is really the only one that I know addresses almost all of the touch points of the GSA, is Open Search Server. I've used it, not recently, but it was good enough a few years ago. I don't imagine that it's gotten worse. It performs all the basics outside of really really strong access controls. It does everything. It's got the basic connectors that you need to pull data in from different data sources. You can add multiple instances of it in a cluster to scale up to a size that's workable for most organizations. Most enterprises in an enterprise search world are not indexing more than a couple million documents. And as far as modern search technology goes, that's small potatoes. Most people are dealing, that have serious search problems, they're dealing with billions, trillions of documents. And at that scale, it's problematic, but millions of documents, especially under 100 million documents, is nothing. OpenSearch Server does have commercial support available, so if that kind of tips the scale for a open source product, then you might want to look at that. Again, the access controls on this OpenSearch server are not great, so I know it does support authentication, but it doesn't have any facilities for saying user A can see these documents but not these documents. So if you need that kind of thing, you're going to have to look at a commercial product or build your own. On the commercial track, there's several that we've seen multiple instances of. The big ones seem to be SearchBlocks, LucidWorks, BA Insights, and IBM's Watson. I don't have first-hand experience with all of those. I have played with Insights and SearchBlocks, but all of these are based on the same basic search technology. They're all based on Apache Lucene. And that's really what any good search engine for plain text search is going to be based on. Lucene's been evolving for like 20 years now, so it's pretty tough to play catch up in that space. Lucene's it's good for 99% of your search tasks. There's really no reason to use something else, and there's not really a close competitor for doing open text searching. So that's really something that you want to look for. So Lucene is kind of the engine for both Elasticsearch and Solr. Those are the two popular search engines that are built on top of the Lucene indexing technology. And if you can, you kind of want to make sure that the product that you're using is based on either Elasticsearch or Solr, because there's lots of developers that are familiar with both of those. And in the inevitable case that you have to build something to work with your search data, those are going to be the easiest to work with. Chances are you can just go hire somebody and put them right to work pulling data out of or putting data into either one of those. As far as these products go, cost varies from product to product. It goes from mild to wild, so you really have to shop around and make sure that A, you're getting what you want, and B, that it's not exorbitantly more expensive than what you're paying for GSA. Either one of those could be the case. All of these more or less have the same features as another, but like I said, you're kind of buying a all-in-one tool, a Swiss Army knife, if you will. So in the commercial space, some of them do certain things a little bit better than the other. Some of them have better, faceted search. Some of them have more connectors. Some of them have a particular connector that you might care about, SharePoint or some ERP system that's hard to get data out of. They might have a really good connector for that, but they might be weak in another area. So you really have to figure out what it is that you actually need and do a lot of shopping around on these commercial solutions to make sure that you get a good balance of what you need versus what's offered. And your last option is the do-it-yourself option. So this is where you dispense with the compromises and go right for the tools that are right for the job at hand. So as opposed to using a Swiss Army knife for a saw and a cooking knife, you're going to use a chef's knife to prepare dinner, not some folding nonsense. And you're not going to try to use that silly little Swiss Army knife saw when you have a chainsaw. It's going to work out way better. Everybody will be happier at the end of the day. So if you're going to build your own solution, I would recommend, and I kind of mentioned this before, that you use either Elasticsearch or Solr. If you don't already have Java developers on hand that are familiar with Solr, I would strongly recommend that you look at Elasticsearch. Elasticsearch, like Solr, is based on Lucene, just like all these other commercial search engines that are out there. But the biggest differentiator between Elastic and Solr is that Elastic employs 50% or more of the Lucene developers. So you can draw your own conclusions about which way feature development in Lucene goes. Odds are that most of the development that's going into Lucene right now is going to favor features in Elasticsearch versus Solr. And aside from Lucene, Elasticsearch itself has a really vibrant developer community. There's tons of plugins. There's data importers. There's all kinds of stuff that's out there for Elasticsearch, and that continues to grow. Aside from that, you probably already have an Elastic implementation in your enterprise. I haven't seen any big companies that don't have at least one project that's using Elasticsearch, so you might be able to leverage some resources that you already have in-house. The other thing is Solr they're both built on Java, but Elastic really has done a good job of packaging Elasticsearch in such a way that it's not readily apparent that it uses Java. All developers access Elasticsearch through a REST API, so it kind of disguises the fact that it's running on Java. So if you're using a different programming language to develop or do integration work with other systems, there's probably a native API for that programming language that this application uses, and it's just going to be more approachable to non-Java developers. And even for Java developers, it's going to be no more or less work than any other platform. And it has roughly the same features as Solr, so I can't really give you a good reason why you would want to pick Solr over Elasticsearch, at least from my perspective. Elasticsearch is also designed a little bit better for horizontal scalability and fault tolerance, and that was all built in from the get-go. Those features that are in Solr, they exist, but they're kind of an afterthought. They were grafted onto Solr pretty far down the road, whereas Elastic was designed from the ground up to be scalable and high performance and have redundancy and all that good stuff. Elasticsearch also has built-in backup and restore functionality, so that makes it easy on your ops folks so that they can have disaster recovery without too much work. Also, Elastic offers full-blown commercial support for Elasticsearch, so all those things kind of work in your favor. Elasticsearch also has the guts of pretty much all search functionality that you've grown accustomed to over the past few years. Search is everywhere, and probably 50 to 75% of the websites that you use are backed by Elasticsearch. Facebook, GitHub, you name it. Elastic, if you buy commercial support, you also get several different add-ons that enterprises are going to care about: monitoring, alerting, and a security plugin that lets you do the access control at a per document basis, kind of the big thing that's missing from OpenSearch Server. So aside from this backend that you need, the second thing that you need is web-based UI for end users. Elasticsearch already provides a REST API, so that's your integration point for new data sources that you don't have a connector for, or other applications that you want to extend search into. But for straight text search, you're going to have to build some type of web UI because Elasticsearch doesn't provide that. You're probably going to want to highly customize that anyway based on your use case, and you're going to want to integrate it into whatever portal it is that you're providing search through. But again, that's not a huge deal. It's a fairly simple UI that you'd have to build. Any developers worth their salt can put that together in no time. The big thing is connectors. So Elasticsearch, that Elasticsearch community has a few connectors out there for pulling data in from a few major data sources. They've also got a database connector that you can use to integrate a lot of applications that the data is pretty straightforward in a relational system. You connect with JDBC, you pull the data in. There's a few systems that do crazy things like encrypt the data in the database or obfuscate things to the point where it's difficult to use that functionality, and those are going to need some kind of an API. SharePoint ERP systems, they kind of fall into that boat. It's also got there's a commercial framework out there. I haven't played with it, but they claim to have connectors for a lot of different data sources. It's called Aspire. For that, I think you'd have to have a separate support contract, so you kind of have to weigh the pros and cons of doing that. And then the other thing that you might need is a web crawler it's kind of your lowest common denominator data importer that goes out and scrapes websites. And there's a pretty good option out there called Nutch that you can use for a do-it-yourself solution. I think that's probably the best one that's out there. I wouldn't look much past that. And again, this do-it-yourself road is probably best for you if things are reasonably simple or crazy complex. Because if you get into the crazy complex case, it's going to be complex whether you're using a commercial solution or not. You're going to end up having to build stuff. You may as well get best-of-breed tools if you're going to have to build a significant amount of stuff. And if it's simple, Elasticsearch, you can literally download and get it up and running in a matter of minutes. And then it's not going to take developers any time at all to build a UI on top of it, so you can have something up and running for a simple case really quickly. And if that's the case, then what's the point in buying something? You're going to spend more time doing POCs and having meetings with different vendors to try and figure out what you want, just to solve a simple little problem that you could put together a solution for in no time. And it's probably going to perform way better than any of those commercial solutions, provided that you architect it wisely and you have developers that know what they're doing. All right, so we'll get on to some of the specifics. Data sources are really your most important thing that you're going to have to deal with. There's quite a lot of them. There's like 75 plus data sources out there that people are connecting to for enterprise search data. Hopefully you don't have to deal with all of them. Hopefully you only have to deal with one or two or three. But I understand that may or may not be the case. These can vary from ERP systems, CMS, CRM, SRM, pretty much any kind of RM type of system. SharePoint, Documentum, Exchange, Active Directory, Wikis, Jira, Source Control, Business Intelligence Systems, vendor and partner websites, news feeds, Hadoop. List goes on and on. These things also have added complexity because they could be spread out across data centers within the enterprise and even in the cloud. Surely you've got some cloud stuff out there that you have to deal with, probably even if you have policies against it. And then there's also hosted applications that you don't really have direct access to the data. You have to get exports, or you might have some kind of API for accessing it, but it's going to be more cumbersome than these other data sources that you can just connect to the database for, because you'll have to come up with some kind of custom connector for pulling and interpreting the data and massaging it into a way that you want it in your search index. So the first thing that you want to look at is data sources that are already being indexed by the GSA. You don't want to disrupt things and take away access to things that are already searchable in your enterprise search solution with the GSA. So you need to make sure that those are covered by whatever option that you choose. And then you're also going to want to look at what else is available out there. Since you have to go through this exercise anyway, you may as well figure out what the gap is between what you're doing now and what you can add to your search index without too much trouble. And then after that, you can deal with whatever nice-to-have sources there are out there, but I wouldn't get too carried away because you really don't want to pollute your search index. You don't want to have to deal with duplicate documents coming from multiple sources. I would advise that you keep it simple and only index the data that you know you need, and really look at the data to make sure that you only index it once. The ones that you really got to look at are the ones that have really complicated data, or the data is encrypted, or for some reason it's not straightforward just to read out of the database. Those are going to typically be your more complicated solutions, things that are hosted applications like Salesforce, ERP systems, SharePoint, anything that encrypts data at the database level that you can't just read straight out. Generally, you're going to want to make use of bulk APIs rather than APIs that access things atomically. So you want to read multiple documents at a time rather than one document. It's not so bad when you're only dealing with a few documents, but if you got to index 1 million documents out of a system, the atomic APIs are going to kill you. Bulk API, you might be able to load everything within an hour out of a data source. With the atomic APIs, it might take you 2 weeks. So clearly that's a deal breaker. The APIs are generally going to be your best bet. For some systems that have simple database, it might be a toss-up between whether the APIs they provide are better than just going straight to the database with JDBC. But you'll have to analyze that on a case-by-case basis. If there's an API, especially a bulk API, you want to use that. Your option of last resort is to use a web crawler, which all of these solutions have, but it's kind of a terrible way to index your data because you don't pick up the metadata that you're going to want from the documents, access control information, all the metadata that's not exposed in the UI. You kind of lose that when you hit it with a web crawler. So it prohibits you from doing any kind of real access control. It's also way slower than just importing things through a bulk API or JDBC. If you have a huge site, it might take forever, especially on a system that's not particularly fast to begin with. I'd kind of point the finger at SharePoint there. So you really only want to use web crawler when you absolutely have to. There's some other problems with web crawling. The biggest one being that everybody's moving to like single-page web applications today. These pages are almost no HTML, and they're entirely rendered by JavaScript. So your web crawler's got to be smart. It's got to be able to go out and use something like Selenium to render all the dynamic content and then index the dynamic content rather than just the HTML, because if you're just looking for HTML, you're going to get no content. Google kind of has it easy because people, they build their site looking for a Google spider to come crawl their site, and it provides a version of the content that's more or less static for Google's benefit. But they're not going to recognize your spider, and your web crawler is not going to pick up the same content that a big search engine like Google will get, because it's going to get the human view that's all dynamic, not the static view that's built for search engines. The other things that you lose are the metadata. I mentioned that things like document sizes, create modification dates, authoring users, departments, organizations, the intended audiences for documents, what type of document it is, that might be available, maybe not. Any kind of indicators about the content, summaries, categorization, tagging, those types of things. Those are all things that you're going to want to factor into your search interface. The more of that stuff that you can get, the better a search UI you can build. And if you don't collect any of it, you're kind of limited to just keyword searching. It might be good keyword searching, but it's still just going to be keyword searching. You're not going to be able to leverage any kind of faceting or filtering, and that's all good stuff that greatly improves the quality of your search experience. The other thing that you're going to want is, if at all possible, you're going to want to get data deltas from these data sources. If you're reading off a data source that has billions of documents in it, or even millions of documents, you don't want to have to do a full scan of all those documents and parse them just to see that there's nothing new. Ideally, you want a way that you can get just the deltas, only the things that have changed since the last time you indexed things. That's not always easy, and that's really why I would give the nod to APIs over just crawling the database, because APIs usually have some type of delta functionality where you can fetch recently modified documents as opposed to just everything. The other thing that you need to watch out for when you're importing data out of these data sources is cascading imports and chicken and egg scenario. So cascading import is where you get an update for one document, but you need to index other documents into that document so that you can search for one document based on its association with other things, because search engines do not store things in a relational type of format. Everything has to be denormalized. So if I say that document A is new, I may have to go fetch documents B, C, and D and merge those into document A before I index it. You want to avoid those types of things if at all possible. It will definitely come up, so you have to kind of plan for these scenarios. The best way to do it is to make sure that they get indexed in the correct order, so that you already kind of have some of that data cached, or at least readily accessible, so you don't have to reach out to multiple systems at the same time to index one document. And you don't have to go back and index all of those separately and go fetch data to index the one that has the other indexed with it. The chicken and the egg is a similar problem where you have two documents, both of which need to get indexed both together and separately. Those are usually many-to-many type of relationships. Most of the time you can avoid those, but you'll probably come up with at least one scenario where you have to do that. And again, you might have to have some kind of pipeline set up where you queue things up waiting for the second component document to come through before you index both of them. In that case, you kind of have to build a smart indexing pipeline. I'm quite certain that none of these commercial products have anything to deal with that type of use case. So these cascading updates and the chicken and the egg scenario are where you're going to have to build custom connectors. I've had to deal with those on pretty much every search project I've ever worked on, so I wouldn't imagine that you're going to be able to avoid it either. Plan on having to build something there. You might be able to get away with it if your case is simple enough. I don't think the GSA has anything to support that stuff, but again, I haven't come across any search solution that I've had to build in the last 5 years that I didn't have to deal with one or both of those problems. So the other thing that you need to look for with your web crawlers is that, well, it's going to have to do some kind of login to some systems. If you have to use the web crawler, chances are it's going to have to crawl a system that has some level of authentication, and it's going to need to know how to do OAuth and SAML and basic HTTP authentication at the very least. It's also going to need to be able to handle status codes so that it can identify temporary redirects from permanent redirects, identify documents that just plain aren't there, and know how to handle the differences between all of those. So it's not trying to go find a document that's never going to show back up, and it doesn't completely remove a document from the index that is only missing today, but it's going to be there tomorrow. It needs to be smart enough to go out and recrawl things and look for that document on a subsequent run if it's a temporary redirect, things like that. There's quite a lot of things that need to go into a decent web crawler. So I would really put that through its paces. If you're buying a commercial solution, come up with a really complicated site that you have to crawl as your proof of concept. So as far as user experience, you're probably familiar with most of these things. So you're going to want to provide advanced text search. Google's always been pretty good about this. So there's always a special format for specifying I want this word and this word to match, or I want this word but not this word to match, things like that. Lucene has all of that built into it. You do kind of have to learn the Lucene format to make use of that, and it's not always ideal for your users to have to learn how to format their text search in such a way that the search engine understands it. It's much better to have a user interface that users can use the interface to construct ands and ors and all these rules for getting exactly what they want. So I would tend to advise people to build a better UI rather than relying on this pass-through crutch of knowing the search engine's syntax. And I would extend that from just constructing ands and ors and things like that to also including faceting. And this is kind of the case where I'm sure you've used 100 websites before that have faceting involved, where you provide some type of basic search criteria, keyword or whatnot, and then the search engine is smart enough to know, oh, this guy's looking for TVs, so it'll provide a customized set of facets that are relevant to TVs, like screen size and refresh rate and what have you. And if it detects that you're shopping for clothing, it will give you facets for colors or sizes or styles, whether it's men's or women's, things like that. So all of that is doable with both Elasticsearch and Solr. All of the commercial solutions are going to have some kind of answer for this. The open search server, it also has it, so I wouldn't look at anything that doesn't support all of that stuff. It's pretty basic stuff as far as search goes these days. Other things that you're going to be familiar with that your end users are going to want are type ahead and spelling suggestion. So you start typing a word and it comes back before you finish and gives you a list of things that you might be looking for based on what you've typed in before. You need some kind of answer for handling misspellings, whether that's autocorrect as they're typing or spelling suggestions as they're typing, or just allowing for misspelled words in the actual search. So you let them type it in misspelled, but you kind of figure out based on the results that you get from the search engine that it's probably this other thing that they're looking for because it's only a couple of letters different, or it's got a partial match, what have you. Most of the search engines, everything that is backed by Lucene is going to support wildcard or regex expressions. If your user base is more tech-oriented, they'll probably tend to lean more towards regex. If they're more lay people, they might use wildcard more. Either way, you want to provide a better search interface a good enough search interface that they're not going to try to rely on those because they perform terribly. So that's another incentive for providing a good user interface. If the difference is between being able to support 1 million users and being able to support 1,000 users, I would invest the time to build a good search interface. Another thing I'm sure you've seen, especially on Google, is result highlighting. So you type in a word, you get your search results back, and everywhere that thing is matched in the resulting summary and document are highlighted. I know Elasticsearch and Solr, they both have answers for that, so it should be reasonably straightforward to implement. Another thing that's probably going to be big, especially if you're dealing with customers, if you're providing an enterprise search solution for your customers, is personalized result relevancy. So this is the case where your application you're providing search through is smart enough to identify who the user is, what company they work for, what language they prefer, maybe look at purchase history, their company's purchase history, anything that might be relevant for providing results that are likely to line up better with the end user. And related to that is saved searches. So people don't like to go type in the same thing, especially if it's a complicated query. So if you have a way to capture these complex queries so that they can be rerun again with minimal effort, that's a big win for as far as user experience goes. Security, this is something that hopefully you don't have to deal with. Ideally, if you have to provide access control on your search results based on who the user is and what roles, groups, what company they belong to, all that stuff has overhead in your search index. It's totally doable, but it's also kind of a pain. So consider yourself lucky if you have a use case where there's no distinguishing who can access what based on who they are or what roles they have, because you're going to have to buy a more expensive solution, and if you build it yourself, you're going to have to address all those things yourself, and it's no picnic. One way you might be able to deal with it is if you have different search indexes for different user groups. That's kind of the easy way to do it. I would recommend doing that if at all possible. If you're using Elasticsearch, you kind of get a lot of this stuff with your support contract. So that's one more reason to build your own solution, because you don't really get that when you buy a third-party product. I don't know of any of them that leverage the access control stuff provided with the Shield plugin from Elasticsearch. Most of those solutions, they build their own security on top of it, and you're probably not going to be able to customize that as much as you like. Really, I've had good success with just kind of rolling my own access control into the search index. So at index time, I identify what users and groups are allowed to see what documents. Only downside to that is that it's kind of fixed in time, so it's hard to add documents, make documents that are already indexed accessible to different user groups, or to add new user groups and change what documents they have access to. So there's really a lot of things that you got to think about with regards to providing security and access control for documents. You also have to decide whether you care about the data at rest being encrypted. If your documents aren't all that sensitive, you can probably get away with just using encrypted hard drives and be done with it. Hopefully you don't actually have to encrypt data outside of that, because if you do, it's going to be a total pain, and it may not be workable at all depending on what your requirements are. I don't think the GSA does any of this, so I wouldn't worry about it too much. The one thing that you probably will have to deal with is the encryption of data in flight. Here we're talking about using SSL for everything, so that's not a big deal. The only thing that you have to do is make sure that you plan for getting certificates and working with your IT guys to make sure that your certificates that you have cover the systems that you're working with. SSL certificates are tied to host names, so you got to make sure that you either have a wildcard certificate that you can apply to any server across your enterprise, or if you're using self-signed certificates, that those are put into whatever update bundles IT pushes out to every machine across the enterprise, because with self-signed certificates, you don't get those aren't going to be included in the certificate authority list that's on your browser, so they have to be extended by IT so that it recognizes your certificate and you don't get the little broken lock when people go to access your site. So it requires at least a little bit of thought there. Let's see. One thing that you're probably going to want to do is you're going to want to, if you build your own solution especially, you're going to want to make sure that you accommodate whatever authentication stores that you have. So here we're talking about possibly having to build integration with Active Directory, LDAP. You might have some kind of mandate that you have to use SAML or OAuth. Those things can get kind of complicated, so you definitely want to plan for spending some time addressing those. It's not something you're going to just slap together in a day or two. I think that's about it for security. So with regards for flexibility, that equals longevity. So you really don't want to revisit the same exercise a couple of years from now when you decide that you need to extend the solution and you can't. That would be a real drag. So you need to make sure that you've got a plan for being able to extend the schema that you use for your search index. Depending on the product, that may be harder or easier. Usually you can kind of design a process for adding stuff to the schema, and if you need to completely change things, there's usually a way that you can phase one index in for another. It's not quite as easy as it is with a relational system, because your schema, once you start indexing data, it's more or less fixed. You can add new fields, but your old documents aren't going to have data for those fields, and you're not going to be able to change things that you've already defined or change the way. Most of the stuff's done at index time with regards to how your schema is designed, the data stored. So even if you can change your schema a little bit, all the documents that you've already indexed will not reflect those changes, and then you just kind of end up with chaos in your search index. So you might find that you have to re-index data quite a bit, especially in the beginning or any time that you're evolving the schema. But you need to be aware of those things and have a plan for dealing with it. You also need to look at how hard it is to extend search capabilities to other applications. Chances are you're not just providing one single search interface. You'll probably have one major one, but you almost certainly want to extend the ability to search against your search index from multiple systems. So you want to know that you can do that and how hard it's going to be, what skills are involved, what have you. You also need to look at how hard it is to add new data sources. Is there already a connector in your vendor's connector library for pulling data out of a particular data source? What is the database? How well does the database connector and or the web crawler work? You're going to need to evaluate this so you know how hard or easy it's going to be to add new data sources. In the case of Elasticsearch, everything's done through a REST API, so it's pretty easy to write something that can turn data into JSON and feed it to the REST API. You don't really need anything other than a simple program. A lot of people run those through like Spark jobs, so you can get massive scale for collecting data out of systems, especially if it's in a distributed store like a NoSQL database or HDFS or what have you. Or even if it's distributed across multiple sites, you can use a big data type of framework to go and collect a lot of that data in parallel and pump it into Elasticsearch. You can probably do the same thing for Solr, maybe not quite so easy. Elasticsearch has got some it's got native plugins for Spark and Hadoop, so it's pretty easy to do it there. And it almost certainly scales better than whatever commercial collectors are out there. All right, another key thing that you're going to look at is performance and scalability. I've seen kind of mixed responses as far as how well the GSA responds, but I do a lot of work with Elasticsearch. It's not uncommon for searches, even complicated ones, to return, in fractions of a second. Almost everything that I do in Elasticsearch comes back, a couple hundred milliseconds. So you really want to be able to perform end-user search in less than a second for the vast majority of your responses. I wouldn't want to go more than 4 seconds. I've had cases where we were doing millions of transactions a minute, and we had a SLA that was under a second. We had to have 95% of our requests under a second, and it was totally doable. So there's really no excuse for providing sub-second response for a much smaller query volume using modern search technology, so I wouldn't be too scared by that. The other thing that you want to make sure of once you meet your performance SLA is, can you scale this thing horizontally if you add more users or content without degrading performance? That's going to be the biggest thing. You don't want to have a hockey stick in your budget if you have to add exponentially more hardware to support an increasing user base. You want that stuff to scale nice and linear. Another thing that you're probably going to have to look at is, can whatever solution I pick run on VMs versus physical hardware? Almost all of you, I'm sure, are going to want to run everything on VMs. It's kind of the nature of the world that we live in. I would definitely ask, if you're buying a commercial product, I would definitely ask what the preference is. I know Elasticsearch-based solutions, they work fine on VMs. I've run them both on physical machines and VMs, and quite frankly, I was able to get more performance out of the virtualized environment than physical machines. But I wouldn't say that that's a blanket statement. I would definitely consult whatever vendors that you're considering for a commercial solution and see what their answers are to that. As far as storage, almost all of these search solutions, based on the way that you have to do things with Lucene, they're going to work better with JBODs, just a bunch of disks, much better than they are with like network attached storage and SAN solutions. Fortunately for you, the JBODs are way cheaper. You're going to get more bang for your buck, but for some reason, most people have resistance to using these. Everybody wants to use their SANs and NAS options that they've spent tons of money on. Yeah, it's easier to integrate into your virtualized environment, but search is, especially if everything doesn't fit into memory, search really needs fast, no-nonsense access to storage. And if you can't provide that, your query performance is going to be terrible. Maybe not terrible. It might still be acceptable, but it's going to be way worse than it could be. You really want just plain old disks attached to your VMs or your physical machines. Don't do anything fancy. No RAID. None of that. Most of your search solutions, especially Elasticsearch, is going to have everything that's necessary for distributing data across spindles and all that stuff that you would be trying to do with RAID or SAN or a NAS solution, but it's going to do it. It's all optimized for running off of JBODs. So I wouldn't try to buck the system and outsmart them. The engineers at Elastic are pretty good. They figured all that out, and if they tell you that it's going to work better with plain old disks, I would trust them. In fact, most of the biggest problems that I've seen with search solutions is ignoring that and trying to push everything onto your SAN. Really, the only time I've seen a SAN work out well is if it was a super expensive SSD-backed, high-end SAN, like an EMC Extreme IO. That is way overkill for an enterprise search type of solution. You buy one of those, and you've instantaneously made your solution way more expensive than GSA was ever going to be. So again, don't do that. As far as supportability, this is not an appliance, so you're going to have to support this thing internally. You need to make sure that IT is prepared for this thing. So you're going to have to define what your realistic uptime SLA is going to be for your support organization or your IT organization to adhere to. You're also going to have to define for them what the recovery time objective and recovery point objective is for this particular solution. They might be really tight if this is a customer-facing solution, a little bit more lax if it's internal only. But nonetheless, you're going to have to provide those details to support and balance how much, whether they're going to have FTEs or what they're going to charge you for providing that level of support. You're also going to have to factor in how expensive it's going to be for your IT organization to keep the lights on this thing. They are going to have to, run regular backups, do monitoring, be prepared for outages, all that fun stuff that those guys get paid for. You're going to have to pay quite a bit of attention to that. So the simpler your solution is, the less trouble that you're going to create for yourself. Don't try to make this thing more complicated than it needs to be, because this is where you're going to suffer. More complexity means more trouble for IT, more things that can go wrong. More things that can go wrong, they will go wrong. I know from personal experience. I used to support a pretty large search cluster, several hundred VMs, and there's always something going on. So the bigger and more complicated things get, the more likely it is that your IT organization is going to have a hard time supporting it. Included in that is regular backups. How onerous is whatever solution you pick? How onerous is it going to be to do backups and restore those things? You want to look for solutions that provide incremental backups so that you don't have to take a full backup every day, every hour. If they're incremental, you can take a backup every 15 minutes, and then that gives you a 15-minute recovery point. And you also want to check to see how long it's going to take to restore a backup. That could be anywhere from minutes to days. So you really need to look into what's going to be involved there. because if you don't do your homework, you might be surprised. Yeah, you might have a 15-minute recovery point, but your recovery time might be hours to days. So if you have, if this is a customer-facing application, you better make sure that you have an answer that's better than if something goes bad, our recovery time is multiple days to restore it. You also need to look at how good the documentation is. Are you going to have to write your own documents for your support organization to be able to support this thing? Or are they going to just be able to go to the vendor's website and get everything that they need and have it be crystal clear? I wouldn't count on it being crystal clear, but more documentation is better, and hopefully it's of decent quality. That's one thing I like about Elasticsearch. Pretty much any question that IT has, I can point them to documentation on the Elastic site, and if they can't figure it out, I can send them to an engineer who can explain it to them. But the documentation exists for pretty much any problem that you're going to have, and that should be true with whatever solution that you pick. So the things that you want to look for, again, I said this earlier on in the presentation, you want to look for a solution that's based on Lucene. Lucene is, it's really the best game in town as far as text-based search goes. There's not really a close competitor, so you don't want anything that's not using that. Preferably, you want something that's using Elasticsearch or Solar, both of which are built on top of Lucene. They just provide a lot of good functionality around it, like clustering, backups, a query API, all that good stuff that you also need. If you don't have Elasticsearch or Solar, you're going to have quite a bit more engineering work when you do end up having to build something custom. So I would really look for solutions that are built on one of those two. Almost all of your commercial solutions are going to be based on one of those or Lucene directly. In any case, you want to make sure that whatever solution that you have does support clustering. You want to be able to grow this thing horizontally. While the GSA, you couldn't upgrade the hardware in the box. That is the worst option anyway. You don't want to have to go add RAM to your machines to support things. It's much better if you can just leave the existing machines running and stand up an entirely new machine, have it join the cluster, and have things elastically expand across the new machines. That's definitely the way to go, not just with this application, but really with any application. Fortunately, Elasticsearch and Solar both have answers for this, so there's no reason to not expect it from whatever solution you pick. We've already talked about developer and IT friendliness. That's worth restating. If you have to build something new, and I assure you that you will, you want whatever you pick to have enough documentation for your developers to be able to figure it out quickly and efficiently. You don't want them bungling around for months building something that's suboptimal. And likewise for IT. You want them to get all the answers that they need as quickly as possible for supporting and building processes around your solution that make sense. Ideally, you've got some number of connectors for whatever solution that you've got. Almost all of them have an answer for a database collector and a web crawler. Preferably, if you have any complicated data sources that one of those doesn't work great for, you have some kind of answer for it. If you don't, you might want to look at some kind of framework like Aspire that I mentioned before. Again, I haven't played with it, but it looks promising from what I've read about it. Things that you want to look out for. I would absolutely discourage you from choosing any kind of solution that's built off a relational database. There's no way that that is going to scale for any volume of documents. you might get 1 million or 2 documents into a relational system before things fall apart, but as soon as you start trying to do complex queries, your query performance is going to go downhill pretty rapidly. And if you ever have to get into the hundreds of millions of documents, it's going to be totally unworkable. It's probably unworkable with far less documents than that. And even if you were able to scale it up a little bit, you would have to have insanely large machines, because the only way relational systems scale is vertically, so adding more hardware to a single machine. Yeah, they have clustering solutions, but they're not great, and they're not anywhere close to on par with the type of clustering that you're going to want that you get from like a NoSQL type of data store like Elasticsearch or anything else that you might use for this. Relational systems are out. I wouldn't even consider it. That's a hard stop as far as I'm concerned. The other thing that you need to look out for is fly-by-night vendors. So this, when Google sprung the end of life for the GSA on everybody, there's kind of a mad rush to put together products to fill this void. So you've got a lot of companies out there that claim to do everything. They might do some of it okay, but I've seen quite a few cases where the offerings were seriously lacking. And this is kind of common in this space. You really need to look out for this, because there just can't be 50 possible solutions for providing a replacement to the GSA and all of them be good. Most of them are built on some combination of open source stuff. Some of them are, have a minimal amount of engineering work. So you want to look for companies that are, sprung up since the GSA announcement. You don't want anybody who's only been doing this for a year or so and slap together a product that they're already claiming does everything in the kitchen sink. And if you are looking at these products, I would definitely do a POC with them, and I would do a pretty thorough one. I'd probably do a POC with multiple commercial products if you have the time. You're probably going to find that one or all of them are pretty lackluster, at least in some respect. And that goes to the next one. A lot of these companies claim to have like 75 or more connectors. Almost all of them are going to have some that, kind of work. Some of them that don't work at all. Some of them that work, but you don't really get everything that you want out of the data source. I wouldn't take anybody for their word that they have a connector for this data source or another. I would want to test it, especially if it was a data source that I really relied on. Don't buy anything before you go test things out. And if they won't let you do that, then walk. Also, make sure that if you go look through their support site, they have answers for things like backups and redundancy, uptime guarantees, performance, sizing recommendations on what kind of hardware you're going to need to run this thing. If they don't have answers for those, they're too young to feel the pain of people asking these questions over and over, or they just straight up don't know. That's a big red flag. So one thing that you need to do is make sure that you're realistic about what it is that you actually need. I've seen more than one organization say, hey, we're going to use this product or another, it does all these features. But they only need a small subset of that, and they turn this into a much bigger project than it needs to be. You're buying a new car, you're not building a space shuttle here. Don't try to make it something that it's not. And if you want to make it something grander, figure out a way to do that in stages. you can really kind of ruin your success with any kind of project like this by not being honest with exactly what you need and focusing on that, and then building on top of that once you accomplish that goal. I wouldn't pick any product because it had all kinds of bells and whistles on it, especially if I didn't absolutely need them. Focus on the features that you really need, make sure that they work well, and buy accordingly. Don't think that you're going to use every single feature that any vendor has, because you probably won't. Also, just because you can index documents from 75 different data sources, I strongly advise that you don't. You're going to run into all kinds of problems. You're going to have multiple versions of the same documents out there. You're going to end up indexing documents that you don't want to be searchable. They have trade secrets or salary information or whatnot. Because if you're talking about millions of documents that you have to index in an enterprise search solution, you're not going to be able to spot check every document out there, making sure that you're not leaking unwanted information into your search index. So I would be intimately familiar with a few data sources rather than trying to index the world. It'll work out way better. Again, I can't stress this enough. Keep it simple. You don't want things to be any more complicated than it absolutely has to. If every additional piece of your solution makes things just a little bit more complicated, quickly you got this crazy Rube Goldberg machine that is inevitably going to break, and it's probably not going to work at the end of the day. You're going to have all kinds of problems with it. Keep it simple. You'll be much happier that way. And with that, I'll take any questions you guys might have. All right. Well, I know we're out of time, so if anyone who's still on the line has any questions for me, by all means, you can email them to me at jpatton@intersysconsulting.com. I'd be happy to give you a reply as quickly as I can get to it. Thank you for joining us, and I wish you the best of luck with your GSA replacement.